The 1 minute just finished my blue buttons. Let these buttons cool down and then we'll remove them from the plate. See you in a few minutes. So let's go ahead and remove them from the plate. They need to be free of all the support before we install them on the trapwall or we install the sockets. It's easy, it's very easy. This is PLA, so it's not that hard. Pull the supports a little bit and they come off really easy. Now let's do the last one. I like 3D printing these parts in PLA. PLA is rigid enough, but I guess my final prints or my final buttons, they're gonna be printed on 3D printed on PETG, which is a more flexible filament and is impact resistant. These are strong buttons, but they're not flexible. They print really nice, but um, they're kind of brittle. You push them too hard, too much, they break. It takes some force to break them, but the final parts should be printed in PETG, which is more flexible and works better for actual mechanical parts. Many people prefer printing these kind of parts from ABS, but ABS is toxic, and I don't want to be breathing the fumes because these things take from 1 to 2 hours. I don't want to breathe in any fumes from ABS, so I'd rather print them on PLA or PETG. So these buttons are ready to install the swappable socket at the bottom and install the Cherry MX Silver Speed on this side, and the cover of the switch as well. That's what we're gonna do next. Let me do the setup and I'll get back to you in a few minutes, and I'll show you how I attach the cables and the connectors, the 2-wire connector to the bottom of the socket. This is a connector with 2 wires for the switches for the switch terminal. We're gonna strip these two ends of the connector, and then we're gonna solder the end to the swappable socket. We're gonna apply some solder to the terminal of the socket. I'm not a technician by any means. What I like to do first is heat up the terminal a little bit and then apply some solder to the end. And these terminals are very small. You don't require much solder, just a little bit, just enough for the terminal to hold the cable, the small cable. That's one end of the socket and the wire, the connector. Let's flip it over and finish the other side. We're gonna do the same. Apply a little bit of solder to the terminal. This way, the way I'm connecting this connector to the keyboard swappable socket, that's gonna help me with the problem of the that I have my original trackball that I made, where I can't swap the switches because they're soldered directly to the board, to the sensor board. So if I ever wanna swap sockets, I would need to remove the wires directly from the Cherry MX switch. If one of them breaks or the one of the cables breaks, and I had a bad connection on the trap ball from the board, the sensor board, or the switch itself, I would need to replace the switch. I tried before when I was building the first track ball. I burned a few switches because these things get really hot. And when I was trying to solder the connector from the board from the sensor board to the switch, I burned like I don't know, maybe five, six, seven switches. The problem I had before is that these small legs at the bottom of the switch, they're really tiny and they're very thin. When I try to solder these wires directly to the switch, the plastic at the base of the switch, the terminals got hot and they melted this plastic base. I burned many of these switches because this plastic can stand the heat when you try to solder the cable, the connector cable directly into these two small legs. I guess this is not a plastic that stands too much heat. Those small tiny legs, they're really thin. Sometimes they even burn or break. My first track ball, the wires coming from the bottom of the board, the PC board and the sensor, they're attached directly to these two terminals, these two tiny terminals. And if something happens or you want to replace the switch, you need to cut the cables, cut the two small cables, or remove them at the bottom of the board. They connect to the micro switch at the sensor board. That's not good because there's a lot of work that you have to do to replace one of these switches the old way I have it on my first track ball. Attaching these sockets to the buttons helps me helps me to install these switches onto the socket, and the socket onto the button. So if anything happens to the switch, I don't need to remove the button itself, unless something happens with the cable that runs all the way down to the main board. Then we need to replace the whole cable and the socket. But that's if the trap-ball is gonna be stationary, is not gonna have a lot of movement. This connection is gonna be very secure. Um, it won't move because you're not gonna be moving the cover, or removing the cover and try to mess with the inner cables. You remove the cap, then you have access to the mechanical switch. That's the way the keyboards work. You remove the any key from the keyboard, and you have access to the mechanical switch, which you can remove and swap it for a new switch. In this case, on my case, I wanted to use these swappable sockets, because I want to be able to replace these switches if they break, or if I want to use a different sensitivity switch. I can just remove this one and put the new switch in place. I don't need to move any cables or remove the socket. The socket is a glue with a very strong glue to the bottom of these buttons, and then I use hot glue to um, to the cables, so they're not pulling. If something happens, they're not pulling the terminals of the socket. They keep the cables stay in place on each terminal. That helps to avoid the cables from breaking if they get pulled off or something. Um, that's the reason I wanted to modify this cover, the top cover, and install these swappable sockets. Swappable means that I can replace these switches from the bottom. These are the buttons that I 3D printed earlier, and I'm gonna install next this swappable socket and the connector directly onto the bottom of the button. We're gonna use super glue, special glue, to attach this to put together this connector, the uh, the swappable socket at the bottom of the button, to keep it secure. And then when it dries, we're gonna apply hot glue to these two two terminals, to avoid the cable, the small cable, to being torn apart or break from the terminal. So next we're gonna put some glue onto the bottom of this button, and then we're gonna press fit this swappable socket onto this cutout, or at the bottom of the button. That's gonna be next.